In this video, we're going to see how to solve quadratic equations quickly. Quadratic equations have the form ax squared plus bx plus c equals 0. For example, the equation 2x squared minus 11x plus 5 equals 0 is a quadratic equation. A, b, and c can be 0 or any positive or negative number. There are 4 methods for solving quadratic equations, and if you practice and learn how to recognize when to use each method, you'll have no problem solving quadratic equations quickly. We'll go through examples of each step by step. The easiest way is using square roots. Then there is factoring, which I'll break into 2 levels, since sometimes it's easy and other times we need to use a few more steps. The third method is completing the square, and the final method is using the quadratic formula. We'll begin with the square root method. I'll leave the form of the quadratic equation as a reference. We will use this method when b of our quadratic equation is equal to 0. Our example is x squared minus 36 equals 0. Notice that both x squared and 36 are both perfect squares. So this is called a difference of squares. A difference of squares, a squared minus b squared, can always be written as a plus b times a minus b, where a and b are the square roots of each term. For our example, x is the square root of x squared, and 6 is the square root of 36. For most of our methods, we want to get our quadratic equation in this form. Now we can solve for x by finding each value of x that makes the left-hand side equal to 0. Since the terms are multiplied together, if either term is 0, the entire left-hand side will be 0. So we can set each term equal to 0 and solve for x. We'll write x plus 6 equals 0 and x minus 6 equals 0. Subtracting 6 from the first equation, we get x equals minus 6 as our first solution. And adding 6 to the second equation, we get x equals positive 6 as our second solution. Since the largest term in a quadratic equation has an exponent of 2, or x squared, we will always get 2 solutions. I'll quickly go through another example of the square root method for a slightly more complicated equation. Here we have 9x squared minus 49 equals 0. This is also a difference of squares. The square root of 9x squared is 3x, and the square root of 49 is 7. We'll set both terms equal to 0 again, but now we'll have an extra step of algebra in solving for x. Moving our 7's to the other side and dividing by 3 to isolate x, we get solutions of x equals minus 7/3 and x equals plus 7/3. By the way, we can use this method even if c isn't a perfect square, as long as b is 0. If c isn't a perfect square, we can just write it as the square root of c in our difference of squares formula, or we can write it as a decimal. Now we'll look at the factoring method. Here, b will not be 0, and we'll want to factor our equation. Our example is x squared plus 5x plus 6 equals 0, and you may already be able to see how to factor it, but we might as well go through the steps that will help you factor this equation for when we get to more complicated equations. First, we find the product of a times c, and then we find all of its factors, or all the different ways of multiplying 2 numbers to get this number. Here, a is 1 and c is 6, so 1 times 6 is just equal to 6. We can get 6 by multiplying 1 and 6, or by multiplying 2 and 3. But since we have a positive 6, we can also multiply minus 1 and minus 6, or minus 2 and minus 3, since the 2 negative signs will cancel. Now we want to find the pair of factors that add to equal b, which for us is 5. If we add all the pairs of factors, we find there's only one pair that gives 5, and that is positive 2 and positive 3. This means our factorization is x plus 2 times x plus 3. We can set each term equal to 0 and solve as we did before. This gives us solutions of minus 2 and minus 3. For each of these examples, you should plug in these values of x back into the original equation and verify that it does indeed give 0. Now that we're warmed up, we can do a slightly more difficult factoring example. Here we have 2x squared minus 11 plus 5 equals 0. This is a little more difficult to look at and instantly know the factorization, so rather than guessing, we can jump straight to our method. We multiply a times c, or 2 times 5, which equals 10. We can get 10 by multiplying 1 and 10, or 2 and 5. And like before, we can also get positive 10 by making both terms in each pair negative. Now we need to pick the one that equals b, or minus 11. Writing these out, we see that the only way to get minus 11 is with minus 1 and minus 10. Now we have an extra step. Our first term is not just x squared like before, so we won't just have an x in front of each term of our factors as we did before. Instead, we've found the factors that add to equal b, so we'll replace b with these factors. This means instead of having minus 11x, we'll have minus 10x minus 1x. Our next step is to group our four terms into pairs. Be careful to include the minus sign in front of the 1x in parentheses. If the minus sign were outside the parentheses, this would also make the 5 negative, which doesn't match our original equation. So you should have your first group of terms plus your second group of terms, both in parentheses. We can simplify the first group by factoring out a 2x from both terms, leaving 2x times x minus 5. Our second group of terms has an x and a 5. We just need to factor out a minus 1. And now we have minus 1 times x minus 5. If we've done the last two steps correctly, we should be able to factor out a common term like we have here with x minus 5. Now pulling the x minus 5 out, it will multiply 2x and minus 1. If you cannot simplify both of your groups of factors to have a common factor like we did here, then you may have paired them wrong, and you can swap the two numbers that we replaced with b and group them the other way. Otherwise, it's probably an algebra mistake. Now we can do our same steps as before, setting both sides equal to 0, and we find our first solution to be 5 and our second solution to be 1/2. The third method is completing the square. This method can be tried when the equation is unfactorable, and you'll know it's unfactorable when you cannot find a pair of factors from a times c that sum to equal b like we did in the previous examples. I'll break this method into 4 steps. First, we'll move our c term to the right-hand side. Now we'll want to find a term that we can add to both sides. This number will be b divided by 2 all squared. Be sure to divide by 2 before squaring. For us, this will be 6 divided by 2, which is 3, and 3 squared is 9. Now that we've added 9 to both sides, we've completed the square, and this means the left-hand side can be written as a perfect square. Finally, we can solve for x. To do this, we'll take the square root of both sides. This will cancel our square on the left and give the square root of 20 on the right. And since squaring the positive square root of 20 or minus the square root of 20 will both give us a positive 20, we need to include the positive and negative roots. This is where we'll get our two solutions. Now we'll move over our 3 by subtracting, and we can simplify our radical if we want, since the square root of 20 is equal to the square root of 4 times the square root of 5. And the square root of 4 is just 2. As a decimal, these two solutions come out to minus 7.472 and a positive 1.472. The final method is using the quadratic formula. This method isn't difficult, but we need to stay organized. The powerful part of using the quadratic formula is that it always works. We could have used it for any of the previous examples we've done so far. We'll use the example x squared minus 7x minus 3 equals 0. First, we'll find a, b, and c. A is 1, b is minus 7, and c is minus 3. Now we'll plug into the quadratic formula. You may be tempted to plug everything into a calculator all at once, but you'll be less likely to make a mistake if you try to simplify first. This may make it quicker as well, and it doesn't matter if you're quick if you get the wrong answer. I'll show a couple of the steps here to simplify, and we find that x is equal to 7 over 2 plus or minus the square root of 61 all divided by 2. This is easier to plug into a calculator, and if we do, we get 7.405 and minus 0.475. Many students despise using the quadratic formula, but notice it was shorter than half of the other methods, and it always works. So if you truly want to be fast at solving quadratic equations, you should definitely practice using this method. These methods will definitely take practice like anything else in math, but I hope you were able to follow along and that this helps you with solving quadratic equations. So that's it for this video, and I'll see you in the next one.